Hello everyone, this is Isha Wang, and this video is a project presentation of my image processing and computer vision lesson. My project name is Image Filter and Adjustment. So first, what did this project talk about? There were three main functions of this project. The first one is zoom and shrink the image. That means we can resize the image with the height and width you like. And the second part is adjust brightness and contrast. To achieve this function, I will convert the RGB color space to YUV color space. Maybe some of you guys are not familiar with what YUV color space does. No problem, I will explain it later. And the third function is applying the filters on the image. There are two filters I use in this project. The first one is HarMix and the second one is Sketch. So before we go into our project, I will first explain some background knowledge. To resize the image, I want to use the bilinear interpolation. But before we know what is bilinear interpolation, we need to first know what is linear interpolation. Let's see these pictures. Imagine that there are 2 points on a rectangle 2D grid, A and B. So linear interpolation is a method of curve fitting. Use linear polynomials to gather new data points which you see within the range of a discrete set of known data points A and B. We all know that this equation must be right. So if we know the x value of z, the unknown value of y can be calculated by this equation. So how do we use bilinear interpolation? The key idea of bilinear interpolation is to perform linear interpolation first in one direction and again in another direction. So let's look at the picture above. You can see 4 points. Q11, Q21, Q12, and Q22. We will first doing the linear interpolation in x direction, that is, use Q11 and Q21 to get the point R1, and then use Q12 and Q22 to get point R2. Then, doing the linear interpolation again on y direction, that is, use R1 and R2 to get target point P. And the equations I listed here. I think we can understand it easily. So, like I said before, I want to transform the RGB color space to YUV color space in order to adjust the brightness and contrast. So what is YUV color space? This color space can encode a color image or video taking human composition into account. It reduces the bandwidth for prominent components so that transformation errors or compression artifacts are efficiently masked. So there are many terms which can be ambiguous, but what we want to know is just YUV. So actually it has 3 components. Y means lumen component, which represents brightness and luminance, and U and Y component stands for prominence component. In order to get YUV color space from RGB color space, we'll define some constant in this way: WR, WG, WB, Umax, and Vmax. We'll first extract the RGB components from the original image and then use these values to create the matrix here, then got what we want. Here are the original RGB image along with its Y, U, V components. And Y, you can see it clearly. It just represents the brightness. So the next term is Gaussian blur. Gaussian blur is the result of blurring an image commonly used in image processing field by a Gaussian function. The visual effect of Gaussian blur is smoothing the edges of the image as well as the color. It will help reduce image noise and reproduce the Bokeh effect. This is now also a low-pass filter. We know that most edge detection algorithms are sensitive to noise, so applying Gaussian blur on an image is more smoothing. Fewer edges are detected, which will help reduce the level of noise in the image. I will use Gaussian blur in one of our filters, which is sketch filter. Let's see this image. If we apply the Gaussian blur on this image, we'll get the second one, which have less noise and less edges being detected. So the last term is color dodge. In order to achieve the sketch filter, we also need a function to loosen the color of the image because the imitation of pencil traces. Dodge changes the brightness of a picture. We would first view the color information in each channel and lighten the base color to reflect the blinded color by decreasing the contrast, which will also result in blinding if color does not change the image. The equation is as follows. A represents the original pixel and B stands for the target pixel and C is the next one. So let's see how can we implement this project. The first step is to find a scale of resize if you want to resize the image. I define M as the horizontal amplification and N as the vertical amplification. Then get the height and width of the input image. Use the character H and W, which represent height and width. Then iterate every 4 pixels respectively and find the float value of the target pixel. Extract RGB elements of the image and do the bilinear interpolation on each of the matrices. The last step is integrating those elements to get the final result. In this example, M equals 1.5 and N equals 0.5. Those are the 3 RGB matrices image and the final result. M equals 1.5 and N equals 0.5. And let's see this picture. This picture is the result of M equals 0.5 and N equals 1.5. So the next function, adjust brightness and contrast. Like I said before, YUV color space can be calculated and transformed by RGB color space. So the first step is extract RGB elements matrix, then create transform matrix. The transform matrix are listed here. We use this matrix to get what we want, which is YUV color space. And if we slightly adjust the Y elements, we will have this result. See, brighter. And compared to U component, V represents more contrast. Then if we change V element a little bit, We can also change the contrast of the image. This is the result. Now this part is Harmonic filter. Harmonic filter is a pretty much simple filter. The algorithm sets the whole picture at most 8 colors. It divides the color range to 8 sections and results in an extremely high contrast effect. And the sketch filter, it has 4 steps to achieve it. The first, remove all the color from the original image. You can use RGB2 function to achieve it easily. And the second, get step-wise output image and reverse the color of each pixel. The third step is establish Gaussian blur function and apply it on the step 2's output image. And at last, lighten the image so that blending with black does not hit the color. This is the result of the image. So this project proposed bilinear interpolation to resize the image, then convert the image to YUV color space to adjust the brightness and contrast. Next is applying filters on this image and output result. Each step is detailed displayed in the report along with the algorithms and results. So let's see the code. This is the original image. For the first function, I just set m equals 0.1 and n equals 0.1 so that the resized image are a little bit larger than the original one. This is the grayscale image of the original one. And the resized red matrix. Green matrix and what is blue matrix? What is blue matrix? Let's see. Yeah, this is the resized blue matrix. Result. The next step is change it to YUV color space and adjust a little bit Y components. This is the result of the adjustment after adjustment. And if we change a little bit of V components, so look at the result here. This is the picture after adjustment of V and Y components. Amazing, see it? And last is to fix filters. This one is Harmonic filter. This one is Sketch filter. Compared to the original image, I think it is so interesting. So what we want to do next is an application. I want to make an image access application which is not that rich material for everyone. So my next step is add more filters and GUI interface and then package the codes into an application. I know that there exist many apps like this, however, I'm curious about how everything works and make an app for myself. Thank you. This is my project representation.